Hey there, my name is Jeremy, and I am the developer of a JavaScript animation library called Shifty, which is what this repo is for. And I recently made some really significant performance improvements to the library for runtime animation performance and memory usage, as we can see in this release here, which is the 2.14.0 release. And I wanted to kind of go over some of the things that I did to make Shifty fast. Some of the things that I learned, uh, and just like this has been a long-term goal for me. I've been working on performance for years, and how do I define that? Well, we can get into that. So I made a tweet about it here, but essentially I've been comparing Shifty to a project called GreenSock, which is definitely it is a great animation library, and it's probably the one you want to use for most projects. I think it's the easiest to pick up and get working compared to anything, including Shifty. But there's some drawbacks to using it, namely that it's a large library and it doesn't have a completely free license, and Shifty does, which is why I so focus on performance. I felt like you should be able to get the best possible performance from an animation library without worrying about having to pay for it or having to worry about the file size. So I can show you how the performance stacks up here. And this is on the latest version of Shifty. So basically, this is a performance benchmarking tool that GreenSock actually wrote, and I forked it just to kind of show how the two compare. So actually, I'll just show you GreenSock, and up until pretty recently, up until this recent release of Shifty 2.14.0, you would have seen a difference in performance. But let's just run this and see what it does. Hopefully this captures it on the screen recording properly, but we're animating 3,000 of these dots, which is a pretty significant load, and we can see that GreenSock is getting, if I can find my mouse in these dots, here it is, GreenSock is getting about 41 frames per second, depending, and it's going to oscillate a little bit depending on your hardware, depending on what else is going on in the computer, depending on a whole bunch of different characteristics. For reference, I'm running an M1 MacBook Pro, so it's got a pretty good processor. So your mileage may vary depending on what device you're using. So this is GreenSock animating 3,000 dots at about 41 frames per second. And this is Shifty doing the same. As you can see, it looks the same, which is the whole point. Earlier versions of Shifty would show this running a little bit more, in a bit more choppy of a way, but we can see that it's getting the exact same frame rates and performance characteristics. They both look great. And I think the point to take away here is that you're never going to be doing this. This is not a practical application of an animation library. If you have 3,000 different animations going on at the screen at one time, there's probably some other design aspects you want to revisit for what you're building. This is just a stress test, a benchmarking tool, just to see like how much load each one can support. But the point is that Shifty can support outputs as good performance as GreenSock. And also, I don't have to show it here necessarily. Well, maybe actually I will. Let's do a fair comparison for the sake of science. Let's go to the debug mode so we don't have all the code pen stuff in the background. So what I'm going to do to show that to show that Shifty has superior memory utilization is that I'm going to do the same test in a new tab for each one. So what I'm going to do here is I'm going to duplicate it. Okay, so this tab is going to run Shifty at 3,000, and this tab is going to run GreenSock at 3,000. I'm going to open up the DevTools. Okay, so I'm going to run it. It's running, and I'll take some performance profiles just for a few seconds. I'll hit play, and it bogs down for a few seconds, which is expected. Stop that, and then go to GreenSock and do the same. Let that kind of get into its runtime loop for a second, and record. Did it record? Oh, no, wrong one. There we go. And then record. Stop that at about 5. Good. Okay, so now that's doing its thing. We can stop these so I don't burn down my machine. But basically, and this is a bit of this is as much of an art as it is a science, because like the tools to measure this stuff are not super duper great. But if you look here, and I know it's a little bit hard to see on your screen probably, but let me see if I can bump this up for you. So Shifty is between 8 and 8.5 megabytes of heap memory usage. And if we look at GreenSock, it is between 12 and 24. So max of 24 for GreenSock and a max of 18 for Shifty. So it's quite a bit lower. And we can also see like this stair-stepping pattern for the memory utilization. That should be about the same on both of them. It looks like maybe GreenSock has a little bit longer of a period here. I'm not sure how that maps to actual performance. As I understand it, there's really only two significant metrics in terms of animation performance, and that is the frame rate, which we saw is the same, and also memory utilization, max memory utilization on the heap, which is lower in Shifty, which is better. So it seems that if GreenSock is been accepted to be the most performant animation library, and Shifty is on par in terms of frame rate and superior with memory utilization, therefore Shifty is the most efficient animation library. But they are also different in terms of what you'd use them for. Shifty is a bit more minimalistic intentionally. It is much smaller. I've got a little table here that you can look at. So we can see that Shifty has it is 5.6 kilobytes compared to GreenSock's 22, and the next the next smallest library is Anime, followed by Pop Motion, and these all do different things. I would say if you wanted to embed, if you just wanted to embed a library that would take care of your animation stuff, your animation logic, and you want to build your own functionality on top of it, Shifty's a library for that. If you want to have something that's got batteries included, that's very turnkey, I think that GreenSock is the better library. But the point is that animation performance is no longer the defining characteristic of GreenSock. It's just the feature set. So as I mentioned at the beginning of this video, I learned a ton about how to make JavaScript faster, and I like to go over that because there's a lot of cool things to learn. I probably won't get to all of it in this video, but let's see how far we can get. So the only file we're going to go over here actually is the Tweenable library, the Tweenable JS file, which is kind of like the core of the library. Everything else is just sort of additional, and it adds features, but it's not strictly necessary. This is the one thing that drives the animations. And you might notice that this is some arcane and ugly code with a bunch of what seems like unnecessary optimizations. And I will say that I don't know that all of these optimizations are strictly necessary. For instance, I try to avoid, it's pretty standard practice for performance optimization to avoid allocating objects, but I try and take it a step further, and I try to avoid allocating variables. For the hottest code paths anyways. It's very hard to measure, and it might be a bit of an over-optimization, so I may end up backing it out, but I'm getting the performance numbers that I want right now, and I seem to be getting incredible memory utilization, so I'm probably just going to leave it for now. But in any case, I'm not going to go over the entire design, just some things I wanted to point out. So first off, I also want to, I want to give credit where it's due, I don't want to, trash talk GreenSock. I learned a lot of what I use in Shifty from GreenSock by looking at the source code and analyzing it for years, because it's incredible work, and the people who developed it are awesome. So a lot of the good ideas here are taken from GreenSock, comparing how Shifty works to older versions of Shifty to how GreenSock has been for years. So I don't want to take anything away from that. I just wanted to make something that was a little bit smaller with a more permissive license. Anyways, so the biggest thing I got from GreenSock was running all the animations in a linked list. So before, every time you make an animation, it would get added to it wouldn't actually be managed internally by Shifty. It would be it would just have its own timeline with its own set of timers, and they all just work independently. But that went under high load. That started to bog down the interpreter or the engine. It wouldn't really make a difference for a small amount of tweens, which is I think what most use cases would need. But for larger, for more intense animations, that could show performance difference. So the first thing I tried was to organize all of the tweens internally as an array within Shifty, and I found that still wasn't fast enough. I still wasn't getting the frame rates I wanted. So what I did is I converted all of that array into a linked list. And basically what I learned is that iterating through a linked list is much faster than iterating to and modifying an array. So for instance, here's the head and the tail. Right here, this is just an internal variable. It's basically this library uses a lot of pointers internally rather than variables that you may be used to. I'm just gonna jump around a little bit, but here in process tweens, this is one of the heartbeats of this whole thing. It basically just takes the head of the list and just iterates through it. And in that through that iteration, animations tweens may be stopped or started or whatever, but it's a linked list, so it just kind of modifies in place and it's fine. So that's pretty cool. It is elegant and very, very fast. And one thing I wanted to point out with these private variables in here is that they look a little weird. Take a sip of coffee here. It's still early in the morning where I'm at. Doing this before work. But anyways, so this function looks a little weird. And what it's doing is that it's actually, I didn't want to keep recreating variables, const A, const B, const C, whatever inside of here. So what I did is, this is an anti-pattern that you should pretty much never do unless you're trying to optimize code to the absolute maximum, which I was here. But basically, this is an immediately invoked function expression, IIFE, as they're often commonly more heard. So basically, this outer function executes. It declares essentially some variables that are just there for the entire time that this thing is in memory, as long as the page is open, essentially. So it declares these variables and returns this function, or this function. And this function gets assigned to this tween props identifier. So basically, it is a function inside of a function, and the reason I'm doing that is that the outer closed variables are essentially my reused variables from run to run. So what that means is that normalized position, normally if I was writing this like a normal function, that would just be const normalized position or let or whatever it may be. But instead of doing that, I'm implicitly doing let up here, and I'm redefining it here, or resetting the value here. So it's basically, this is an absolute micro optimization, and it is dangerous because you have run the risk of not resetting your variables correctly. So I really wouldn't recommend doing this unless you have extremely hot code paths like this. But this runs thousands of times a frame, so it needed to be as fast as it possibly could go. And I think that's probably the one big trick that maybe is unique to this library. Again, I kind of took the linked list thing from GreenSock, and a few other things, for instance, only computing the actual position of the tween once if possible. The eased position once if possible. A lot of little things. The other big thing that I saw GreenSock doing that I kind of took for here as well is kind of treating animations as retained mode graphics. So what I mean by that, retained mode. Can't type. Media mode. So essentially, what this means, as I understand it, is that retained mode basically means that if you have many things going on in an animation at once, if you update one, the other parts of the scene don't get changed. It's more direct. It's more maybe intuitive. Whereas with immediate mode, if you have if you have 3 circles in your scene and you redraw one, it actually it doesn't update the rest of the scene, and you have to manage cleaning up the parts that you don't want anymore, or re-rendering the whole thing, whatever the case may be. Point being is that as far as how this affects animation on the web, is that the DOM is a retained mode graphics environment, and something like the canvas, for instance, is an immediate mode graphics rendering environment. So it's easier and I guess less work on the animation engine side to focus on to assume that it's a retained mode environment, which if using this on the DOM, which most people are, that's exactly what it is. Same with SVG. So point being is that when an animation has not moved or updated in Shifty, it does not get rendered. And that was incidentally kind of half true in earlier versions. I just made it more intentional and more of a defined behavior in Shifty 2.14.0 because it makes for performance improvements. So for instance, previously delayed animations would be rendered on every frame up before they even started. So I changed it so that wasn't not the case because they're not moving, so they don't need to be rendered. And it's the render. The render is the most expensive operation of any animation tick. So yeah, probably the linked list and this weird, closure defined variable trick that I found here. That again, that's the most unique thing. Other things like, I try and only search for, I try and get the current time once per frame because you should only have one, timestamp that you're working with per frame because those date calls, date, this is essentially calling date.now. Oh, here it is. It gets used variously down here, but basically is calling date.now once per frame for various performance improvements. Trying to see what else here is interesting. Also, yeah, so this is the linked list management stuff that I kind of just took from here. It's you don't have to necessarily rewrite your own linked list. There's plenty of examples how to do it correctly. In fact, I've made some bugs trying to get clever with it. So just go with the established patterns for linked lists. It's much, much easier. It's very recommended to not try and get clever with it or reinvent it. So there's a lot of old-fashioned looking code. I love ES6. I like terse code. I like modern code, but that comes at a very small performance cost. Not enough to really worry about in day-to-day software development. But if you're trying to make the absolute most optimized performant thing that you can, you need to go kind of old school with how you write things. So that's why, for instance, these aren't up here as instance members. They're just defined. It's syntactical equivalent, but it's when it gets transpiled, it makes a function call to define all of these. And function calls cost something, not very much, not usually much enough to get excited about, but again, this is performance oriented, so it needs to be fast. So I tried to minimize the function calls as much as I possibly could. And down here, I'm trying to find, right, so this set config is a pretty significant function in here. It's basically what configures and starts a tween. And there used to be object assigns in here, but I removed those in favor of just plain loops. And again, I try and reuse variables to prevent reinitializing them if I can in this function and throughout the library. But essentially, rather than using object assign to assign, from one object to another, I just loop through it. It's slightly faster. And once I get rid of all those, internal function calls, even though they were very cheap, they were still something, they added up. But that's when I started getting frame rates that matched that of Green Sock. So it's just a lot of that stuff. It's just kind of very, it's not that magical code. It's just sort of ugly and, kind of inelegant code. Normally I'd make this a lot easier to read and easier to follow and try and separate concerns more. But like all of those techniques that make for more readable, maintainable code come at a performance cost. But that's kind of it. It's like it's not too much magic. I would say that the takeaway is, making code faster, conceptually is very simple, right? Like you just need to do less work. That's all there is to it. Make the computer do less things and it'll go faster. The computer will go the same speed that it does, but if it's doing less work, then it'll get it all done faster because the speed is constant. The trick is finding where that work is happening. And Chrome DevTools are very helpful with that. Although it's a little bit hard to read, for instance, what's in all of this stuff sometimes. Like it's not, let me see if I can get rid of this and make it a little bit smaller for you. It's a little bit hard to read what's in here. Like you can sort of see what it's doing, but it's kind of reading what this does is a little bit of a skill unto itself. Let me go to Shifty here for a second, because that I know a little bit better. Here we go. So, yeah, like it's not totally clear where the bottlenecks are. I'm not sure that I understand enough to necessarily explain it, to be honest, but the tools are there to instrument it, I guess is the point. But a lot of it is also guesswork. That's why it took me years to get this far. Because it's not really clear, like, this is what you should optimize. This is where the bottlenecks are. Like, there's tools that help with that, but it's like, at the end of the day, especially if you're doing something with high load like this, it's very hard to determine where the bottlenecks are. So it's just a lot of experimentation, a lot of trial and error. But, if you get enough time and if you stick to it, you can get there. You can make your code incredibly fast if you're willing to make some trade-offs with how readable it is. I would never write code like this normally, but now that I have, very efficient. And I think especially with the closured memory technique that I showed you, it's very low memory utilization. So maybe if you that's something you can do to improve the performance or memory usage of your app, is just try and avoid redeclaring variables. Just reuse variables as much as you can. Reuse objects, that whole thing. And that's about it. If there's anything else that folks want to know about how I made Shifty so fast, leave a YouTube comment, you can start a discussion on the repo, which GitHub just added this whole thing. Where is it? So yeah, you can actually just start someone actually asked a question. So if you have a question, just, drop it here and I'll get to it when I can. But thank you for watching. I hope that, you learned something from this, and if you like Shifty, that you got something out of it. But thanks for watching, and hope to hear from you. Thanks. Have a great day.